On the night of September 14, the sky broke its own rules. An interstellar comet, designated 3I, Atlas, lit up against the black canvas of space in a way no one predicted, no one prepared for, and no one could immediately explain. What began as a faint, distant speck, barely within the reach of the world's most powerful telescopes, suddenly erupted in brightness, surging far beyond its expected curve. The outburst was violent, rapid, and baffling. Amateur astronomers from Tokyo to Arizona, from Chile to Europe, stared at their screens in disbelief as their carefully plotted light curves veered off script. This wasn't a subtle drift. It was a vertical leap. A jump so sharp that even veteran comet watchers found themselves whispering the same words. "This isn't normal." The numbers confirmed the shock. In less than 72 hours, Atlas brightened by 1.6 magnitudes. To the untrained ear, that may sound small, but in astronomy's precise language it meant the comet was suddenly reflecting 4 times more light than models allowed. Imagine sitting in your dark living room at midnight, only for the room to be flooded with light as though someone had cranked an invisible dimmer switch. That's what the cosmos had just done. At first, explanations swirled. Perhaps a buried pocket of carbon dioxide had burst, venting gas in a sudden jet. Maybe it was an illusion caused by excess coma, the hazy shroud of gas and dust fooling the instruments. But then, night after night, the reports stacked up. The data was consistent. The surge was real. The curve had broken, and it wasn't coming back. That night, the amateurs owned the story. Their raw data, uploaded in real time to forums like Cloudy Nights, became the pulse of a global watch. What is normally a slow, predictable climb in comet brightness had transformed into a sheer wall of points leaping past expectations. Professionals, cautious by nature, had no choice but to pay attention. Because when the numbers break, it's the universe itself sending a message, one you may not yet have the words to decode. And the message didn't stop with brightness. As September unfolded, the chemistry itself rewrote the rulebook. Webb's infrared spectrograph revealed something almost unthinkable. The comet's coma, the vast atmosphere surrounding its icy core, wasn't dominated by water, as almost every known comet is. Instead, it was overflowing with carbon dioxide. The ratio was staggering, 8 parts carbon dioxide for every 1 part water. To put that in perspective, most comets flip the balance entirely. Water leads, with carbon dioxide and carbon monoxide playing secondary roles. But for Atlas, water was little more than a side note. Its engine ran on different fuel entirely. By mid-September, Atlas was spewing 129 kilograms of carbon dioxide every second. Imagine a truckload of frozen gas exploding into vapor every single minute from a nucleus no wider than 3 kilometers. For scale, that's smaller than most city parks. And yet, this tiny world built an atmosphere 700,000 kilometers across, nearly twice the distance from Earth to the Moon. The effect in the sky was otherworldly. Observers across 3 continents began reporting an emerald glow cutting across the pre-dawn darkness. Normally, this ghostly green, caused by diatomic carbon, C, excited by ultraviolet sunlight, only blooms when comets dive much closer to the Sun. But Atlas defied expectations. It glowed green weeks too early, far brighter than models dared predict. One astronomer described it bluntly. The comet looked like a chemical torch, and then came the geometry. Atlas displayed something rare, an anti-tail. While most comet tails stream away from the Sun, Atlas projected a luminous spike seemingly pointed toward it. In reality, this was an optical illusion, a trick of perspective caused by its retrograde orbit slicing through its own dust trail. But even illusions can reveal deeper truths. Polarimetric measurements from Warsaw delivered another shock. Atlas showed an unusually strong negative polarization, reaching 2.7% at just 7 degrees phase angle. Most comets barely dip below 2%. In comet science, polarization isn't noise. It's structure. It tells you how dust grains are shaped, aligned, and organized. Atlas's dust was not behaving randomly. It was ordered, almost like filaments or aligned sheets, as though electrostatic forces were arranging the particles into patterns. Some scientists shrugged it off as extreme but natural. Others quietly whispered a more uncomfortable question. What if this wasn't just random dust? What if there was order because something had imposed it? By late September, tension wasn't just in the data, it was in the silence. Public images from Hubble and Webb, plentiful through July and August, suddenly dried up. September's logs showed nothing. Observatories cited orbital geometry, the comet's shrinking solar distance making observations too risky. But the timing was suspicious. Just as Atlas began breaking the rules, the world's best eyes in space seemed to look away. And then came October 3, 2025. The date circled on every planner's calendar. That day, Atlas swept past Mars at only 0.19 astronomical units, just 28 million kilometers. Close enough that every orbiter circling the red planet scrambled for a shot. The Mars Reconnaissance Orbiter, the Trace Gas Orbiter, Mars Express, all debated whether to risk their instruments for a glimpse. Internal memos later revealed the tension, scientists lobbying for every frame, operations teams warning about safety. Because this wasn't just another comet. This was an interstellar visitor. The third ever confirmed, after Oumuamua in 2017 and 2I, Borisov in 2019. But unlike either, Atlas didn't play by the rules. Oumuamua was silent, no tail, no coma, just a flickering light curve and a trajectory still debated today. Borisov behaved exactly as expected, a textbook comet. But Atlas? Atlas was something else. Brightness surges. Carbon dioxide dominance. Polarization extremes. A green halo ahead of schedule. It wasn't breaking physics, but it was shredding every expectation. And when anomalies pile up, speculation rushes in. Some dared the question. What if this isn't just a comet? Could Atlas be a probe? A disguised artifact? A technological visitor masquerading as a natural rock? The theories leaned on three pillars: its unfamiliar chemistry, its strangely ordered dust, and the sudden blackout of public data. Carbon dioxide as fuel or camouflage. Polarization as a signal. Silence as secrecy. Scientists pushed back, insisting natural explanations still fit, exotic chemistry, unusual dust structures, and observation constraints. And yet, unease lingered. Because even if Atlas is only a comet, it's a comet like no other we've ever seen. A town-sized nucleus wrapped in a planet-sized atmosphere. An engine fueled by something unexpected. A glow that came too soon, too bright. A dust structure whispering of hidden order. And silence, at the very moment curiosity burned brightest. What does it mean? What story are we really watching unfold? For now, the answers lie not in whispers but in data. As Atlas continues its journey, telescopes will turn again. Spectra will flow, cameras will fire, and perhaps the rules of comets, or the rules of the cosmos itself, will be rewritten once more before our eyes. Because in the end, the universe doesn't owe us clarity. It only offers signals, numbers, spectra, shadows, light curves. And it leaves us with the question, do we treat them as footnotes, or as sirens? If you've been captivated by this story, by the way the cosmos can open new chapters of mystery when we least expect it, make sure you're subscribed to our channel. We'll be following every anomaly, every unanswered question, and every hint that reminds us just how little we truly know about the universe we live in.